This is actually August 25th, 2020. Vector math. I'm going to zoom in here just a second. So this is a new branch of math altogether. Right? So you've learned regular algebra, and what I'm about to teach you is a field of math called linear algebra. Back when we still had Algebra 1, Algebra 2 in geometry, this would have been usually in Algebra 2 in the matrix section, if you've ever worked with a matrix before. If you've never worked with a matrix before, it'll be okay, because it doesn't look the same. So, vector math. To add vectors, you must have a couple things. Thing number one is like units. Thing number two is the vectors must point along the same line. The vectors must point along the same line. That's what makes like terms. When you're in Algebra 1, what makes like terms? Or in your math classes, what's a like term?
The variable.
The variable. So if one of the variables has x squared, you can only add it or subtract it from x squareds. Or if it's the cube root of y, you can only use the cube root of y. So the new rules here is you must have like units and you must have same line. Now by same line, that means you could point in the same direction or the exact opposite direction. Same direction or exact opposite direction. So let's do a couple of examples of that. So these are your basic ones. Some examples are, if I have a vector that points to the right and it is 10 newtons, and I want to add it to a vector that points to the right at 5 newtons, I can add those two because they both are measures of force, newtons. We haven't gotten to that yet. We're going to get to that today. 5 and 10. 5 plus 10 is exactly what you want it to do, 15. And it would be at 0 degrees. Because some of you have done enough math to know this is 0 degrees or 0 radians. This one is 90 degrees or pi over 2 radians. Put this up here where you can see. This guy over here is 180 degrees or pi radians, and this one is 270 degrees or 3 pi over 2 radians. Now, how many of you are familiar with radians? 1, 2, 3. Nathan, you don't count. 4. You do count, but not for physics 1. Okay. So radians is now on the list of things we make sure we know how to do. Yeah. Yep. Yep. This is the class, too, that I get the most variation in math skill. So I never know what I'm going to get. And that's fine, because I reteach it anyway. But it's interesting because I get kids that are sophomores that are just now in integrated 1 or integrated 2. And then sometimes I get seniors and they're in calculus. So like last year I had several kids that were in calculus but were also in physics 1. So they would look at the math, except for this part because they've never seen it before. I don't think they teach it anymore. I don't think it's in the integrated curriculum at all. Which I guess the good news means I don't have to reteach it because you learned it wrong. Isn't that sad that my first assumption is that? I used to teach math though, so I know these things that happen. It's just stuff that happens. Not about teachers. Math teachers doing the best they can. Just like I do the best I can. But it is interesting. Okay, so we, in here, will not use radians except when we do angular motions. So you can do all degrees until we get later in the year, and I'll warn you when we get to that. So if you can do the 360 degrees, you're going to be okay. All right. So why do I say this is at 0 degrees? I say it's at 0 degrees because the direction that that sum vector would point is directly along the x-axis. Points directly along the x-axis. And if I get going too fast, just tell me. Because as I said to Nathan yesterday, I've been doing this since I was 18. I'm now 49. There's not a lot of thought going on. There's just making sure my students are okay. All right. Now, let's do another one. Let's do... Let's do that one. Negative 27 meters plus 15 meters. What would that one be? What would be the obvious choice here? Negative? How about 12? I can't math. It's okay. No, it's all good. Last year in stats, I had a moment when I said, okay, so that's 12 out of 100, which is about what, like 13%? No, it's not. It was, in my defense, it was 7th period. So, by 7th period, we're all dead and kind of stupid. So, negative 12 meters. Now, this one, because it points to the left, you can either say negative 12 meters or you can say 12 meters at 180 degrees, or if you're feeling frisky, 12 meters due west. All of you that love navigational directions. 12 meters due west. Do I need to do some vertical ones, or do you have the idea?
How do you write the number if it's vertical?
If it's vertical, you do the exact same thing. Let's do one.
How would you tell if it's vertical or not?
Ah, from just the numbers? Hang on to that question. That one's a coming. Okay, so let's go 20 meters per second plus 10 meters per second. This would be north. See, because with vectors always have to have two pieces of information. You have to have an amount, and you must have a direction. Otherwise, I can't answer the question. So if Tyler had said to me, I want you to add 20 meters per second to 10 meters per second north, I couldn't answer the question because I don't know where the 20 is. But these are both north, and they're both the same units. So in this case, my answer would be 30 meters per second due north or 90 degrees. Because that would be saying the same thing. Now we're going to do the thing you don't like. What if they're not in the same direction? We won't do what if they're not in the same units. If they're not in the same units, you can't add them.
Yeah.
Okay? Dylan cannot add meters to feet per second. They're not the same thing. At some point this year, some of you will do that, and then you'll see it and you'll be embarrassed. But it's okay. It's really okay. This is the class where you can make everything wrong, and it's still going to be okay. I'm still going to be okay with you. Okay, so now what about this? 4 meters east plus 3 meters north would be 4 meters east. And how do I do the next one? What you do is once you draw your first vector, you put the tail of the next vector at the end or tip of the first arrow and go from there. So tail is over here. Tip of the arrow is over here. So then I draw the next one 3 meters north. So there's our 4 meters east, 3 meters north. What is the result of that action? So here's how you have to think. Vector math is called taxicab math. Okay? It's called taxicab math because in real life we want to take the shortest, you probably heard, the shortest distance between 2 points is a straight line. And you already know what the hypotenuse is going to be here. Because I bet if people that know absolutely no math in their life at this point can still do this one. It's 5 meters. But now you have to tell me what a direction is.
That'd be northeast.
Northeast, true, not enough.
Yeah,
Not sufficient.
Not exactly northeast.
Because northeast would actually be 45-degree angle. The only time you get to use northeast is exactly at 45 degrees. Otherwise, you have to give the angle. The reason we call this taxicab math is because let's say that Dylan wanted to go to Julia's Bakery. Don't we all? We should have a field trip there. I wonder if we could walk there and back in an hour and a half. We could totally try. Okay, and then I lose my job. Okay, so let's not do that. All right, so it's called taxicab math because if I hire a taxi, they can only take the streets, right? They can't go directly there. Like a bird could go directly there, but a taxicab can't. And so we call it taxicab math because what does the cab have to do? The cab has to go up this street and over this street, yeah, to get where we're going. But the bird could fly straight there. So you already know, how did I get the 5? What bit of math that you already know did I use to get the 5? Pythagorean theorem, right. How do we get the angle? Okay, this is where some of you are kind of stinky. It's okay. I want this angle right here. Angle theta. Angle theta, I need to use one of those cute little trig ratios that I know. Sine, cosine, or tangent. I want to use the one from the numbers they gave me, not the ones I calculated. Why do I not want to use the ones I calculated? In case they're wrong, because if I miss it the first time, now I miss it the second time. We call that in physics a double jeopardy situation. So let's say that Reuben does this right. He gets 3-4, but then he writes 15 because brain and hand stopped communicating briefly. Okay? And now he goes, oh, I want to use sine. Sine of 3 over 15. Now his next answer is also incorrect. Even though you're thinking correctly, your process is correct, but your numbers are not. Typically, if your process is correct, even if the numbers are wrong, we give you the second set of points because we've already penalized you for the 15. You lost the 15 on part A, but now on part B, when you use it again, but you use it correctly, you get full credit. Does that make sense? Because otherwise we'd be punishing the same mistake again. So typically we try to avoid double jeopardy on the AP Physics exam. Okay, so how do we find this? Well, the ones they gave me were these two. So I'm going to want to use tangent. Tangent of theta is 3/4. And then I use that cool thing that says undo the tangent. Undo the tangent. Not take the reciprocal. Undo the tangent. And I do it on both sides because this is algebra. This is regular people algebra with a little trig thrown in. So now theta is whatever that is. And that one I believe is 37 point something. This is the Egyptian triangle, by the way. Any idea why it's called the Egyptian triangle? The pyramids in Egypt were based on those ratios for sides. Some of them. Not all of them, but that's where it came from originally. And you may know or you may not know, Euclid Euclid was Egyptian. He was from Alexandria, so he's Egyptian and Greek. You know what I mean? Greek owned the country, but he was born there. So that's how you find the angle. And then I make sure my calculator is in degree mode, because we're in degrees right now. Then I go, okay, undo tangent 3/4, 36.9. Okay, so 37. We would also take 36.9. How do I know? Now we got to give the last bit. Where does the angle start? It starts here and it curls up to that, right? So we would say this is 37 degrees north of east. We started east and you curl 37 degrees north. Start east, curl 37 degrees north, you get to my angle. So 37 degrees north of east. Or just 37 degrees. Okay? So far so good? I'm going to let you loose on your own now. Try this one. So we are left 6 and we are down 2. Left 6 and down 2. That's what that says. So you can put these as 6, positive and positive, but it's left 6 and down 2. So most of the time we would write this as negative 6 and negative 2. Okay. Any one you want to find is fine, as long as you give the directions that match it. I'll talk about that in just a second. So go ahead and get this. See if you can do that. Let's see, square root of 10 is what, 3.5? No, 3.5 is 12. So it'd have to be like 3.1 or 3.2. So 6.3? Somebody help me out here. 3.16. 3.2. Okay. Would have been within one decimal. Okay, and our unit is meters. I will say this a bunch of times this year. No naked numbers. No naked numbers. They better have units on them. Don't let those numbers run around naked. It's just wrong. Okay, so 6.2. Now, Ruben asked me, and Tyler was probably thinking the same thing. That number comes out 6.1, and there's a bunch of decimals, yeah? And so Ruben said, do we do significant figures? AP has decided that's one too many on a time test. So the answer is no. You do not have to do significant figures correctly for physics. And the crowd went wild. Ah, right? Okay, if you don't know what it means, just smile and go, yeah, I like that. Because it means you have to figure out which, and I don't call them significant figures. I call them measured digits. So what did we measure here? 6, and we measured 2. And the next number would be estimated. In this case, it would be 0.0. So the one I estimate is not significant because I didn't actually measure that closely. I couldn't. My materials didn't allow me, or my tools didn't work, that kind of thing. So what you do is you do something reasonable. So what would AP have taken on this answer? Would they have just taken 6? No. Why would they not just take 6, even though that would be significant figures in this case?
It's 2.5.
It's too far away. You know it's not just 6 because it's the square root of 40, not the square root of 36. So they're going to expect to see 1 decimal place. They will take 1 decimal place or 2, but if you use more than that, they'll count it wrong. Because you couldn't measure it. With the numbers you were given, it couldn't be that precise. So do something reasonable when you round off. Does that make sense? And we can talk more about that as we go. But just do something reasonable. So 6.2 meters. Now we got to figure out direction. And this was the thing Tyler was asking me about. What angle do I want to find? Well, Miss Wilson is going to find this one. The one that's inside the triangle. Because then I do tangent. Whoops, you can't see that. I don't need the square root for this part now. So I'd have opposite over hypotenuse, and these would both be positive. So theta, yeah, it sounded like it was trying to be. By the way, have I mentioned how much I hate the buzzers instead of the bells? I miss our bells. Dr. Justice asked if we could have them back, and they were like, no. Everybody in the county has to do the same thing. So.
Teachers, students, we are working on the fire alarm. Please disregard the fire alarm. They are working on it. Thank you.
Okay. So I get 18.4 inverse tangent.
Oh, how do you put it in the radio or whatever?
Oh, on here you have to do mode.
I forgot my calculator at home.
So you are in radians, need to be in degrees. Right. Okay, 18.4. Now, how do we label this angle? I know it's got to have a south and a west in it, but how do I label it?
Oh, it's a south of west.
It would be south of west. So that's one answer you can use. Some of you more mathy people could then find this angle, and it would be 198.4 degrees, and then you don't have to give a direction at all, because that's always measured from 0. If you give an angle like that, it's always measured from the positive x-axis around. If you were feeling particularly intelligent that day, you could also use negative. You could start on the positive x-axis and go clockwise and get what? Negative 90. What's this piece? If that's 18, what's this one? 72. So this would be 71.6. So 90 and 71.6. You could also list this as negative 166.6 degrees. Guess which one we prefer? Either one of these. Don't do the negative one if you can help it. Okay? All right. I'm going to stop there.